The question wants you to find the enthalpy of combustion of methanol. So you should always write the equation for what you want to find. Alright, and you need to know the equation for the definition. So enthalpy change of combustion is you take something, right, and you burn it in oxygen. So methanol, right? CH3OH, okay, and we're gonna burn it in oxygen, alright, and becomes what? Carbon dioxide plus water. Okay, then you balance, make sure the equation is completely balanced. So we have one carbon, you have one carbon dioxide, you have 4 hydrogens, you need 2 water. Okay, then you count the oxygen. How many oxygen do we need, right? You've got O2 plus 2O is 4 oxygen atoms. So you have 1 already here, you need another 3 oxygen atom, which is why you need 3 over 2 O2. Okay, so this is the equation for what you want. This is delta H combustion of methanol. Okay, this is the number that we want. What you do, as I mentioned to you, after this is the first step, write the equation for the enthalpy change you want. You look at the information given to you, and you look at each compound here, and you use the data given, you find, alright, which one involves any of this compound, or rather from any, you look at this compound, you can find whichever data involve them, alright, and you can write equations. So when you write arrow downwards or left, right, they are all equations. So for example, right, what else do we know about this first compound methanol? Enthalpy of formation, right? So the definition is what? Formation is make from elements. So we can make this thing from its element, which is carbon, oxygen, and hydrogen. Okay, now the element must be in their standard state. So this is O2 gas, carbon solid, hydrogen or H2 gas. Also, all this must remember the right state symbol. So this is a liquid, this is gas, this is gas, this is liquid. Okay, now, so we have these elements. They can be used to make methanol, but you must balance again the equation. So you only want oxygen atom to make methanol, so you should plus half O2, right? And you need 4 hydrogen to make methanol, so you need 2 H2. So this is the up arrow. This is formation of methanol, so it's minus 239. Okay, now next we need to do formation of this oxygen, but formation of oxygen is basically 0 so you can just plus the 3 over 2 oxygen. Alright, this is doing nothing one. Okay, so or you can think of it as carry over. So you don't write the arrow, it's also fine one. You can just don't write this arrow and it's still fine. So don't forget to carry. Okay, whatever that didn't react, you carry. Alright, now so you go on to the next compound, CO2. What do we know about CO2? Look at the information here. So every enthalpy given to you, you must know the definition and the equation. So enthalpy change of combustion of carbon is to burn carbon plus oxygen. Alright, so burning something in oxygen to give a oxide product, which is CO2. Complete combustion. So must be C solid plus O2 gas gives CO2 gas. So this is the equation for this definition, you see. So this is the part that you ask me, you don't know what to do. Every enthalpy change definition, you must know the equation. So go and study the definition properly. Okay, now, so this CO2 from this data given to you is make from, or rather is to burn carbon oxygen to give CO2. Okay, so that's what this enthalpy change means, and that you can make CO2 from burning carbon. So what you want to do when you do any cycle, you must close the loop one. Okay, you must close the loop. So if this thing, alright, the reaction that we want to use, like delta H combustion, doesn't involve any of this, you cannot close the loop so you have to like something else go to this. Okay, but now because it's the same material, alright, enthalpy change of combustion of carbon converts carbon to carbon dioxide, and then this is data, and then I look here, carbon dioxide, what involves carbon dioxide? This one involves carbon dioxide, so I can use this equation. Now this equation, what is involved? Make carbon dioxide from carbon and oxygen, and I look here, carbon, oxygen. Once the material is the same, you can close the cycle. So when you close the cycle, you arrow basically from the same group of compounds, or two, or from, depending on the definition, but in this case it's from carbon, oxygen, from CO2. Alright, so you have already oxygen here and here. Actually, half oxygen plus 3 over 2 oxygen is the same as, you could have written this as 2 oxygen molecule. It's the same. Alright, so you could have written even this is also fine. Alright, so we need one O2 to make CO2. So we already have enough, so it's okay. You can just make the CO2. Alright, so no need to add anything. The next, water. So we look around the data given to you. What? It involves water. Enthalpy of formation of water. So what is enthalpy of formation of water? It's make water from, right, oxygen and hydrogen gas. Because enthalpy of formation is make compound from its element. So that means you can make this compound from its element. What element? Oxygen, hydrogen. Again, it's the same stuff. Alright, it can be found here. So you don't go and do another arrow already. Alright, you go and close the cycle, because the arrow from the same place, you can close the entire cycle. So arrow from, if it's the same group of things, you can draw the arrow from there. You don't get draw another separate one already. Okay, so this is the equation, this is equation, this is equation, this is also equation. So must be balanced one. Alright, so one carbon can make one CO2, it's okay. And then you need another O2, which is found here, it's okay. Alright, so you can, it's automatically already balanced. So this will be minus 394. Now next we want to make 2H2O. So enthalpy of formation of water is 286. So this is 2 times minus 286. Okay, make sure that you follow the stoichiometry. Enthalpy of formation of water is to make 1 more water, but this is 2 more water, so you need 2 times enthalpy of formation of water, 2 times minus 286. Now we check the stoichio to make sure everything is balanced. To make 2 more water, you need 4 hydrogen atom or 2 hydrogen gas, right? 2H2. So you have 2H2 here. H2 is balanced. Oxygen, you check. You need 2 oxygen. Do I have 2 oxygen? Yes, I do. Alright. So just now I have 2 O2. One of them is used for CO2. The other one can be for H2O. So total I need 1, 2, 3, 4 oxygen comes from here is enough. Alright. So this is everything is balanced. This is a closed energy cycle. Alright. So therefore, what we want to find, path 1 equals path 2. Okay. So meaning, alright, delta H combustion. Okay, path 1 will be equal to path 2, but this is going against the direction. Alright, this is the same direction. So we should subtract this number. So minus negative 239. Alright, this one is opposite direction, right? Path 1 equals, no, these two are the same direction. So path 1 equals path 2 this way. So this one opposite direction, but these two going in the direction that we want. Alright, we want to go from here to here. So we should add the negative 394. So look at the way I do it. Alright, I will do the operation in the correct way and keep the sign separate. Okay, so I should add because it's same direction, but it's a negative number, so I put in the minus sign, the minus 394. Okay, and I should add this number, so I plus 2 times negative 286. So please follow the step by step what I teach you to do. Don't try other things. Write the equation for the enthalpy change you want to find. For each compound, look for data that involve them. The reaction involve them. Can be involve them to form the product, alright, or could be involve them, okay, to form the product, or could be involve them as a starting material or a product or something. It doesn't matter, okay, as long as the reaction can involve these things, you can use that data. And how do you use it? You write the equation, you write the equation, you write the equation, you write the equation. But if they involve the same material, you can join to the same point and close it out. If they don't, then you can write separately. So I think that's a mistake you made in the other energy cycle that you show me. Alright, so this is the correct energy cycle. Okay, there we go.